Okay, today we're going to be discussing rhombi, which is the plural of a rhombus, and squares. And these are our Common Core content standards and the mathematical practices we'll be using in the assignment today. Previously, you've determined whether quadrilaterals were parallelograms and/or rectangles. Today we're going to recognize and apply the properties of rhombi and squares, and we're going to determine whether quadrilaterals are rectangles, rhombi, or squares. We've got two new vocabulary words, rhombus and square. And as I said, we've also used the term rhombi, which is the plural of a rhombus. A rhombus is a parallelogram with all four sides congruent. A rhombus has all the properties of a parallelogram and the two additional characteristics described in these two theorems. Its diagonals are perpendicular, and each diagonal bisects a pair of opposite angles. Okay, so let's look at solving problems using the properties of a rhombus. We're told that the diagonals of rhombus WXYZ intersect at V. If the measurement of angle WZX is 39.5, find the measurement of angle ZYX. Why don't you pause the video for a moment and draw this sketch and mark down what is given so that you can follow along as we work the problem. So since WXYZ is a rhombus, we know the diagonal XZ bisects angle WZY. So the measurement of angle WZY is equal to 2 times the measurement of WZX. So in order to find the measurement of WZY, we simply multiply the measure of WZX by 2. We get 79. So since WXYZ is a rhombus, we know that WZ is parallel to XY and ZY is a transversal. Since we have a transversal, we've got consecutive interior angles. We can use that theorem, and we know that they're equal to 180. We know the measurement of one of the interior angles is 79, and we know that both of them together would be 180. So we can subtract and get the measurement of ZYX is equal to 101. Okay, so now let's look at this from a different viewpoint. The diagonals of a rhombus WXYZ intersect at V. So if WX is 8x minus 5 and WZ is 6x plus 3, we need to find x. Now remember, one of the properties of a rhombus is that all sides are congruent. So we can set these two quantities equal to each other and then solve for x. Now it's time for you to check your progress. So pause the video and work the problem, then come back and check your answer. All right, so we know that the measurement of ABC is 2 times the measurement of CBD. We're trying to find CBD. Well, if it's 2 times, we simply divide ABC in 2 because it's being bisected. So 126 divided by 2 is 63. Very good. Let's try another problem. So pause the video for a moment, work the problem, then come back and check your answer. Very good. This one was simple, wasn't it? You set the two quantities equal to each other and solve for x. So x is equal to 6. Now a square is a parallelogram with 4 congruent sides and 4 right angles. Recall that a parallelogram with 4 right angles is a rectangle, and a parallelogram with 4 congruent sides is a rhombus. Therefore, a parallelogram that is both a rectangle and a rhombus is also a square. So this Venn diagram summarizes the relationships among parallelograms, rhombi, rectangles, and squares. Now all of the properties of parallelograms, rectangles, and rhombi apply to squares. For example, the diagonals of a square bisect each other, as in a parallelogram, and are congruent, as in a rectangle, and are perpendicular, as in a rhombus. So here's some theorems we can use to prove that quadrilaterals are rhombi and squares. You can use the properties of rhombi and squares to write proofs. So here we're being asked to write a paragraph proof. You might sketch this diagram and write down what is given and what we're trying to prove so you can follow along when we work the problem. So since it's given that LMNP is a parallelogram, we know that LM is parallel to PN, and angle 1 and angle 5 are alternate interior angles. So that means that angle 1 is congruent to angle 5. It is also given that angle 1 is congruent to angle 2 and angle 2 is congruent to angle 6. So since angle 1 and angle 6 are both congruent to angle 2, then they are congruent to each other by substitution. And angle 5 is congruent to angle 6 by substitution. Therefore, LN bisects angle L and angle N. By theorem 618, LMNP is a rhombus. So let's try this on our own. First of all, look at what we're given. Is there enough information given to prove that ABCD is a rhombus? So pause and make a note of what you're given, what you still need to prove that ABCD is a rhombus. Are you given enough information? Yes, you are. If one pair of consecutive sides of a parallelogram are congruent, then the parallelogram is a rhombus. Very good. Now we're going to use conditions for rhombi and squares. Hector is measuring the boundary of a new garden, and he wants the garden to be square. He has set each of the corner stakes 6 feet apart. What does Hector need to know to make sure that the garden is square? So since opposite sides are congruent, the garden is a parallelogram. Since consecutive sides are congruent, the garden is a rhombus. Hector needs to know if the diagonals of the garden are congruent. If they are, then the garden's a rectangle. By theorem 620, if a quadrilateral is a rectangle and a rhombus, then it is a square. Sakin has a shape he knows to be a parallelogram, and all 4 sides are congruent. Which information does he need to know to determine whether it's also a square? So pause for a moment and read through your options, then come back and check to see your answer's correct. You're right. He needs to know that the diagonals are congruent. Earlier, you used coordinate geometry to classify triangles. Now, coordinate geometry can also be used to classify quadrilaterals. Here we're going to, first of all, plot these vertices. We're going to plot them on a coordinate plane so that we know exactly what size we're looking at and which 2 points make up the diagonal. From the graph, we can tell that the parallelogram is a rhombus, a rectangle, and a square. So if the diagonals are perpendicular, then ABCD is either a rhombus or a square. The diagonals of a rectangle are congruent. So if the diagonals are congruent and perpendicular, then ABCD is a square. So first of all, we're going to use the distance formula to compare the lengths of the diagonals. So if you haven't plotted your points, it's going to be difficult to know which 2 points to use. Notice that the diagonals have the exact same measurement. They're congruent. Now to determine whether they're perpendicular, we need to see if the slopes are opposite reciprocals. And yes, they are. So since the slope of AC is the negative reciprocal of the slope of BD, the diagonals are perpendicular, and the lengths of BD and AC are the same, so the diagonals are congruent. So it is a rhombus, a rectangle, and a square. So now we're going to check your progress. First thing I would do would be plot the points to find out which ones are the diagonals and which points we need to compare. So pause the video and work this out and then come back and check your answer. You're right. It is a rhombus, rectangle, and a square because the diagonals both have the same measure, square root of 26, and the slopes of the diagonals are opposite reciprocals, so they're perpendicular. Very good. All right, you're ready to begin your assignment. Good job.